Let's talk about insertion sort. Well, first, let's talk about what inserting is. Let's say I have a sorted list here, and I want to insert the number 3. How do I do that? Well, I can take a look at, starting from the right, and say, is 5 greater than 3? If yes, then move left. Is 4 greater than 3? Move left. Is 2 greater than 3? No. Okay, so then 3 must go here. And then I can insert 3. All right, so we took a sorted list and we inserted the element, and now the list is sorted afterward as well. So what if we take an unsorted list? Can we use this to sort the list? Yes, that's what insertion sort does. So with insertion sort, we start with an empty list, and then we take each element in the unsorted list one by one. We loop through all the elements, take the element, and insert it into the list. All right, how do we insert 2? Well, is 8 greater than 2? Yes. Okay, so 2 must go over here. So at every step, insert is trying to figure out where the latest element should go. Where should 4 go? We know it should go here. How do we know that? Because we start from the right and say, okay, 4 is less than 8, so it must go here. But 4 is greater than 2, so it must go here. So at every level, we're able to insert. So what insertion sort does is it loops through all the elements. Each element, it says where it should go. So 1 should go here, so we're going to put 1 here. And 3, where should it go? It should go here. So we're going to put 3 here. Okay, so the logic behind insertion sort is if you take a sorted list and you insert a new element, you get out another sorted list with that element. So if you take a bunch of unsorted elements and you insert them in one at a time, at the end, you're going to get a sorted list and it's going to have all the elements. That sort of reasoning uses induction. We say, in the base case, we have an empty list that's sorted by definition. And in each step, when we insert an element, it was sorted before, it's going to be sorted afterward. And so after we insert all the elements, we have a sorted list. All right, so let's write this up in code. So with code, what we're doing is we start off with the empty list. And then for each element in the unsorted list, we're going to insert it with this logic into the list. And then we're going to return the sorted list. So how does this insertion logic work? Well, we take the element, so let's start here. We start with element 8, L equals 8, I equals 0, so it's pointing here, and current index is going to point to where I starts. That's what this does. And then for the while loop, we're basically just going to move things over, move cur I to where it needs to go. We want cur I, current index, to point to the place where we should insert the element. So while current index is greater than 0, well, it's not greater than 0, it's 0. So this doesn't even run. And what that basically says is we should insert 8 at the index 0. So that's what we do. All right, next iteration should be more interesting, hopefully. So the element is 2. I is going to point to, well, I is going to be 1, it's going to point to 2. And then current index is once more going to be instantiated to where I is. All right, so now we say, okay, actually I should put current index down here because it's pointing to the sorted list sort of. I mean, it doesn't matter, but we're saying, is the element in the sorted array 1 before current index greater than element? Is 8 greater than 2? Yes. All right, so that means that we should move 8 over and put 2 to the left. But how do we move things over? Well, actually, we just copy it and leave 8 there to be overridden in the future. So we're going to decrement current index. And then the second run, we're all the way to the left. So that's what this says. We're all the way to the left, so we should stop. And then current index is going to point to where you should insert the element. So 2 is going to be inserted here. All right. So what happens when we're processing 4? Well, once more, we're going to start here. We're going to say, is cur I minus 1, whatever's there in the sorted array, is 8 greater than L? Yes. All right. So then let's copy it over and consider the next element. Is 2 greater than 4? No. Okay, stop. All right, now let's insert 4 where current index is. So we're going to put 4 here. So hopefully you're seeing how this works. I'll do it one more time just so you can see. So with 1, is 8 greater than 1? Yes. All right. Is 4 greater than 1? Yes. Okay, move 4 into here. Is 2 greater than 1? Yes. Okay, move 2 into here. Oh, we're all the way at the left now. So what does that mean? That means the while loop stops and we must insert here the 1. All right, and then for sake of completion, 3. We start here. Is 8 greater than 3? Yes. Okay, so 8's going to be copied over. What about 4? Yes. All right, so 4 is going to be copied into here. What about 2? No. Okay, so 3 must go here. Boom, there goes 3. So that's how insertion sort works here. If we wanted to do the inline version, sorted is where you return a new list copy that's sorted. Inline sort, insertion sort, will modify the original list inline. So when you're modifying inline, it's the same logic, except this time instead of having a new list, you are just moving the element into the list by looping through the current indexes, and then when you want to insert the element, rather than putting it into sorted array, you put it where it belongs in the original list. We can see that when we have the code here, we start off with the unsorted list, then we print that out sorted, and then we can see the original list was not modified. But then if we run the inline sort, then the original list is modified. And the same thing goes for C++ implementation. We have an unsorted list, then we inline sort it, then we can see that it's sorted. Likewise, we can return a copy that's sorted and print that as well. And the C++ implementation is the same thing, just written in C++. So here's the header, and then here it is with templates and all that jazz. Okay, so the last thing that we should talk about is runtime. This for loop is going to run O of n times. And in each iteration, it's going to do a certain amount of work. How much work? Well, it depends. If, in the worst case scenario, you have to swap all the elements in, like let's say we had the list 2, 3, 4, 5, and the element we're trying to insert is 1. Well, in that case, this while loop is going to run all the way through the list, and 1's going to be inserted here, which means we have to copy everything over. We have to copy 5 over, 4, 3, 2, and then insert 1. So that's n work. So in the worst case, you're doing O of n work in an iteration. In the best case, if we were just inserting the number 6, the while loop wouldn't even do anything. And so we could just insert it right away. So that's O of 1 work in the best case. This is work per iteration. So if you have O of n iterations, that means that in the worst case, you have O of n squared work, and in the best case, you have O of n work, because you multiply the number of iterations times the work per iteration. Okay, that's it for insertion sort.